Pearson's R correlation coefficient. Statistical tool for parametric test. British mathematician Karl Pearson published his work on the correlation coefficient in 1896, which was built upon the earlier work of British eugenicist Francis Galton and French physicist Auguste Brevet. Assumptions: this is a parametric test. Sample's tawdry variables must be normally distributed. Run the Shapiro-Wilk test. Variables are continuous. Variables work in pairs. Outliers are not allowed. The variances of these variables are relatively similar. Run Fisher's F-test. The Pearson correlation coefficient is a descriptive statistic. It summarizes the characteristics of a data set. Specifically, it describes the strength and direction of the linear relationship between two quantitative variables. The Pearson correlation coefficient R is the most widely used correlation coefficient, also known as first, Pearson's R, second, bivariate correlation, third, Pearson product moment correlation coefficient, and lastly, the correlation coefficient. Pearson's correlation is parametric, in the sense that it relies heavily on the mean parameter for the two objects. This means that Pearson's correlation might have higher validity for a normal distribution, with a centered mean, than for a distribution that is not normally distributed. The Pearson's correlation coefficient formula is as follows, where R refers to the Pearson correlation coefficient, X refers to the values in the first set of data, Y refers to the values in the second set of data, and N is the total number of values. It is a statistical method that measures the similarity or correlation between two data objects by comparing their attributes and calculating a score ranging from -1 to +1. The Pearson correlation coefficient, R, is the most common way of measuring a linear correlation. It is a number between -1 and +1 that measures the strength and direction of the relationship between two variables. A high score indicates high similarity, while a score near zero indicates no correlation. This method is parametric and relies on the mean parameter of the objects, making it more valid for normally distributed data. If you need writing assistance, drop us a note at the email address below. The Pearson correlation method is the most common method to use for numerical variables. It assigns a value between -1 and +1, where 0 is no correlation, 1 is total positive correlation, and -1 is total negative correlation. This is interpreted as follows. A correlation value of 0.7 between two variables would indicate that a significant and positive relationship exists between the two. A positive correlation signifies that if variable A goes up, then B will also go up, whereas if the value of the correlation is negative, then if A increases, B decreases. Two objects with a high score near +1 are highly similar. Two uncorrelated objects would have a Pearson score near 0. Two objects that correlated inversely, meaning one is falling when the other rises, would have a Pearson score near -1. Considering the two variables age and salary, a strong positive correlation between the two would be expected. As people get older, they tend to earn more money. Therefore, the correlation between age and salary probably gives a value over 0.7. If Pearson correlation coefficient, R, is between 0 and 1, the correlation type is positive. The variables are in the same direction. If Pearson correlation coefficient, R, is 0, there is no correlation, and there is no relationship between the variables. If Pearson correlation coefficient, R, is between 0 and -1, the direction of the variables are in the opposite direction. Here are the interpretations for the different values of Pearson correlation coefficient, R. If Pearson correlation coefficient, R, is greater than 0.5, strength is strong, direction is positive. If Pearson correlation coefficient R is between 0.3 and 0.5, strength is moderate, direction is positive. If Pearson correlation coefficient R is between 0 and 0.3, strength is weak, direction is positive. If Pearson correlation coefficient R is 0, strength is nan, direction is nan. If Pearson correlation coefficient R is between 0 and negative 0.3, strength iron is weak, direction is negative. If Pearson correlation coefficient R is between negative 0.3 and negative 0.5, strength is moderate, direction is negative. If Pearson correlation coefficient R is less than negative 0.5, strength U is strong, direction is negative. Some examples of variables for correlation. The more coffee you drink, the more hours are spent awake. As salary increases, so does spending. The more classes a student misses, the more likely their grades are to decrease. As ice cream sales increase, so does murder. If you need assistance for your papers, email us at academicpapersassistance@gmail.com.
For more discussions and similar videos, please like, share, subscribe and click the notification bell.